So, welcome to Moshang USA show. This is Lydia. Mark Twain said, everybody talks about the weather, but nobody does anything about it. So regarding climate change, what shall we do? How do we know what measures are effective, whether the cost is worth it? The answer may surprise you. It turns out that there's a model, and anybody can use it. It can help answer these questions. Here to discuss it today is Mr. Tom Hafer. Tom developed the systems for neutralizing rockets and drones. He currently attempts to keep up with teenagers on his robotic teams. Hello, Tom.
Hello, Dr. Liu. Yes, I will use a model called En-ROADS, which is an interactive climate model that allows you to see what activities and what policies make a difference and which ones don't make so much of a difference. First of all, En-ROADS is a model that's developed by a consortium that includes Climate Interactive, Ventana Systems, and MIT's Sloan School. And you can find it by searching for En-ROADS climate model. I'm going to share my screen and show you that, if I might.
Sure.
So here we are. So here's Google and En-ROADS climate model. And we'll just search on that. And the very top thing is En-ROADS. There it is. And so there's a splash screen, and we'll close that. And so here's the model. And it looks very simple, but it's actually quite deep. And so I'll just show you a few of the features of it. So first of all, at the top, it shows you a graph of the global sources of energy. So these include contributions from coal, oil, gas, renewables, bioenergy, nuclear, and then there's a category for some new invention of energy generation. It could be fusion energy, it could be anything, whatever. Then this graph here shows the net greenhouse emissions over time. So it goes from the year 2000 to the year 2100. In other words, all the way to the end of the century. And there are really two lines on this graph. The black line is the baseline. In other words, what happens if we don't change anything from what we're doing now? And then the current scenario shows what happens if we change some of the variables. And so we'll do that later on. And then over here, it shows the expected temperature rise by the year 2100. In other words, when we're very old people. And just to show you some of the power of this, there are some things up at the top here that show different graphs that you can use. So on the left-hand side, you can look at the financial graph and the cost of energy. On the right-hand side, you can change it to sea level rise, if you like, and then you can set everything back the way that it was by going return to default. So what we're going to do is look at the variables that are down here in this section. And again, this is fairly deep because they have the major categories shown here. But for example, coal, you can see, well, what are they counting? So if you click on it, this tells you, what do they mean? Well, coal is pretty obvious because coal is coal, but there are a lot of sub-variables that you could change. For example, you can either subsidize coal or you can tax coal. You can decide what year the tax or subsidy starts. When does it stop? What does that mean in the percent reduction of coal utilization? What year does that reduction start? When does it stop? And then you have a toggle switch that says stop building new coal infrastructure. And all the variables have things kind of like that. So each of the slider bars allows you to change the variables. So we'll look at those in a moment and show you what some of the impacts are.
Oh, very cool. So what can you do with this model? And what does it tell us about the measurements such like electric vehicles and renewable energy like solar panels, also the Green New Deal?
Okay, well, that's exactly what this model addresses. So, for example, down here under transport, you can change electrification. So right now, we have very little electrification of transport. Not that many people have electric cars, not that, you know, a small, very small percentage. So it looks as though it's zero. It's not quite zero. But we can see what would happen to the greenhouse gas emissions and the temperature change by the year 2100 by changing this. And so this model is probably only accurate, like any model, to within plus or minus 10%. So if the temperature change is less than 10% of 3.6 degrees, it's probably meaningless. So let's see what happens with electrification of vehicles. And this is on a global basis, not just here in the United States. This has to happen worldwide. So we'll slide it all the way over to where it is highly incentivized, as the model makers think can possibly happen. And so you can see over here, hardly any change. And hardly any change in the net greenhouse emissions. So that surprises a lot of people. How about renewables? What if we really incentivized renewables? Let's see what happens if we do that. Okay. So going all the way to the right, where they're highly subsidized, again, very little change in temperature rise and in CO2 emissions. What about coal? What if we make coal extremely expensive, basically punitive, basically put it out of business? So we'll slide that all the way over here. And what you see is that over here, the percentage of energy that's attributable to coal has gone way, way down. But the actual overall reduction in carbon dioxide emissions and the change in temperature is very little changed. So bioenergy. So here's bioenergy down here. What if we went to biomass and things like that? How much change does that make? Well, basically none at all. So unfortunately, those are things that are darlings of the Green New Deal, and they really don't make that much of a difference. So most of what's in there has very little scientific justification.
Oh, that surprised us a lot. So what does that Build Back Better policy will cover? Well,
so there are a few meaningful steps that we can take. If I can get my notes to line up properly here. So one of them is building energy efficiency. If you make your buildings highly energy efficient, you actually do make a meaningful change in temperature and in CO2 emissions. So that's hopeful. Another one is methane gas reduction. If you can reduce the amount of methane that's released into the atmosphere, it makes a significant difference. Technological carbon removal. We don't have large scale carbon removal technologies, but if we did, that actually makes a somewhat significant difference. And in this model, the one that really makes a difference is simply pricing carbon. So in simple words, a carbon tax. So if you highly tax carbon, that makes the biggest difference of all in terms of CO2 emissions and also in terms of net effect on temperature. So,
but the question is, are those measures that may play some effective roles are included in the Build Back Better policy?
Well, for the most part, not. Some have a little bit of inclusion in Build Back Better, but for example, carbon removal, there's very little in the way of funding for that. Methane reduction, there are some good words, but they don't really know how to do it. There is some for energy efficiency in buildings, but notably absent is the carbon tax, which turns out to be sort of the biggest winner. And since all of these things, I showed extremes of doing those, and extremes probably aren't going to work. They're probably not going to be politically practical, but there are some combinations that could be included in a bill. So if we go sort of halfway across the bar for methane reduction, if we go halfway across the bar for energy efficiency in buildings, if we include some reasonable degree of carbon removal and an increased but not excessive carbon price, then you see that we really do make a significant difference. We bring the carbon dioxide emission rate much farther down, actually to below where it is today, this being 2020 right here. And the net increase in temperature stays almost within the United Nations guidelines for temperature. So there are some practical measures that could be undertaken. They're just not what we're doing principally.
Yeah, I think we hope more people will understand the real science behind this and improve our thinking and to seek for the right policy to really solve the problem.
Part of the problem is that these models have been shown to politicians and the people who make policy, but unfortunately they're wedded to a lot of the old ideas that seem like good ideas. Oh, let's all go out and buy Teslas. Not that I'm picking on Tesla, I love Elon Musk, but we see that really doesn't make much difference. And as an example of that, I was at a webinar recently where we went through exactly this same exercise, and we showed to everyone's satisfaction that vehicle electrification really made very little difference. Nevertheless, at the end of the webinar, the moderator, who is well versed with this model and understands it very well, asked everyone on the webinar to please sign a letter that was being sent to Congress asking that the postal fleet of vehicles be electrified. So the question that this model raises is, aren't there better ways to spend that money? It would cost billions of dollars. Suppose that we went out and used that money to fund research into carbon removal technologies. Wouldn't that be a much better way to do things? And just as a final note, carbon dioxide stays in the atmosphere for centuries. So once it's there, and it only is removed very, very slowly by nature. So carbon dioxide removal technologies are actually one of the very few ways that we have of actually reducing carbon dioxide in the atmosphere, because otherwise, once it's there, we're living with it and it will continue to increase global temperatures. So that's the lesson for today. If you have any questions, if you'd like me to try some other variables, please feel free to ask.
One question is, when we talk about the model, how accurate the model is, because like the pandemic model, it takes time to prove the model is very predictable and very accurate. And regarding to its climate model, how do you prove that it's very accurate and better than other models? And also, do you have any data to demonstrate that it can really mimic the reality instead of just staying in a model?
Well, let's see if, well, any model consists of a lot of assumptions, because climate modeling is an extremely complex undertaking and we don't even understand all the variables. But here is a graph that we can look at historical data. So we'll compare En-ROADS to temperature history. So here is En-ROADS prediction, and here is the actual temperature history. So you can see that it's pretty accurate.
Yeah.
Let's look at some other things. How about greenhouse gas net emissions history? So here is, again, the En-ROADS model, and then the actual data from 1990 up through roughly 2015. And somewhere in here, there are other comparisons with other models. I don't remember exactly where they are. So you'll have to trust me on that one, but it has been compared, looking forward into the future, it's been compared with about 7 other models that take a very long time and a very sophisticated set of personnel to run. And it's been found to agree, generally speaking, with kind of the median of all those models. So it has been vetted about as well as any of these types of models can be.
Yeah, it looks like pretty accurate and also seems like the champion of many existing models. So thank you very much for this very interesting model. I think we just need to let more people know it and play with it, and understand more knowledge about climate science.
Well, if I might say, I'm hoping that by publicizing this model on your channel and in papers that I've written, that people will begin to question the assumptions that have been with us for so long about what do we need to do about climate change? Oh, if we just all go out and buy electric cars, if we just all go out and install solar panels on our roof, that will take care of the problem. And unfortunately, the answer is that it won't. And in fact, this model has also dashed some of my favorite hopes. For example, I'll show you. So I'm putting everything back to the baseline cases. So a couple of my favorite choices were afforestation, which means planting more trees, because trees do interact with the carbon dioxide cycle. So what happens if we go out and plant lots of trees? Well, unfortunately, not very much. Another particular favorite of mine is increasing nuclear power. Can we build new, safe, small modular nuclear plants? So what happens if we greatly increase nuclear power? Well, not very much. So unfortunately—
that's a big surprise, because I think one of the arguments of current policy is that we want to introduce more nuclear energy. That's one of the most clean energy indeed. But it looks like in its model, it doesn't play too much to reduce global.
Where I see it playing is in the longer term. I think that if we are going to go to carbon-free energy sources, if we only stick with wind and solar as our principal sources of energy, we're always going to be hostage to the cycles of nature. So we've either got to have massive, massive battery storage for backup power, or we've got to have alternate sources. So I think that a mixture of new nuclear plants, which can be made much simpler and much safer than they are currently, and renewable energy sources for generating power when the sun is shining and the wind is blowing would be a good mixture. So I think that for the long term, that's a path that we should go down, but we shouldn't expect too much to come out of it in the near term. The other lesson of all this is that unless we do some of these things that we've discussed today, it is going to get warmer. So one of the principal things that we need to do is to acknowledge that, and then to accommodate what's going to happen as a result of climate change. It's just going to happen, and we need to adapt to that. Fortunately, we're good at that.
Yeah, and it won't happen in one day. So it's a very slow process. So there's no need to be panic.
Right, right. Well, and actually, that does make another point that needs to be made. In order to publicize climate change and to get the public on board, some members of the climate science community have been talking about climate apocalypse. Oh, mankind is going to go extinct if we don't decommission all our coal plants tomorrow. Well, this model shows that things happen gradually. There is no apocalypse. It may get less comfortable. There may be bigger hurricanes and more floods. But on the other hand, good things will happen as well. A lot of arable land will become available in northern areas such as Canada and Russia that wasn't really productive before. So there are pluses and minuses, and we just need to adapt our thinking to accommodate that.
Yeah, also are some very extreme, like tree huggers. They even claim we should not have babies. Human beings should start to have least population to combat the climate change. So I think its model also says no to that kind of extreme methods.
Right. Let me set the graphs back to what they were in the beginning, just so that so I'll show you. So there are two things that I didn't go into. One is population growth, because that's not a policy that I really think that we should be taking on. If you discourage population growth, it actually doesn't make a huge difference. If you encourage population growth, you're making the problem worse. Now, there is one variable that I didn't get into because, again, this isn't something that I would advocate, but if you stifle economic growth throughout the world, that makes a big difference. But that means that people are living in poverty. So that's not a policy that I want to embrace. So I didn't mention that in my original presentation.
Very cool. Thank you so much.
Good talking to you.